Okay, what's up everybody? Let's begin. And as usually I just like to do a quick summary of yesterday's stream, and it was all about splitting up the water solver or fluid solver in these different parts so we can. It's pretty much about reworking it in such a way that it is more like it's more similar as how I imagine the gameplay will be in the end. And that's what we're doing right now. No, Amena Pro, I don't think you missed a lot. I had a break for 3 weeks, I think, and just returned. Nah, we're doing water, and that's what we're gonna start with today. So this is pretty much the end flow we want. Player adds water to a point, and that starts a process where we add more and more and more and more water until we find a minima, or if the player stops adding water. And if minima is found, we want to add a fluid unit to that point. Like we want to add more water, add more water, add more water while the player hasn't stopped pouring the water. And during this process we will find out what amount of water we can allow for without it overflowing, basically. So when the player stops adding water finally, we're gonna take those values, like we can add this much water without it overflowing, and then we either fill it up to that part or dry it out. Yeah, something like that. I appreciate it, Amena Pro. I think I had so the 3 weeks prior to this one, I was on vacation basically. But now we're back. No, I haven't done creatures just yet. I still want to get this terraforming in place, and then we might start looking into creatures. I think the plan is to release a playable demo of the terraforming, because I really want to get that part correct so it's fun to play and fun to create, sorta. But okay, so yesterday we finished this part, but we had a little bit of a problem, and it was that the water was only spreading in one direction, and I think we figured out why, but we just didn't get the correct fix in place. So we're gonna do this. Let's see, unvisited points. Let me show how it looked, by the way. Visited points. Fluid spread. So if we do okay, we're gonna do it like this. So the idea is that we start adding water, but this is just finding the minima algorithm, part of the algorithm. So we're gonna add 1 unit of water, see if we find a minima. If we don't, we render and we're gonna try and find a minima, and then we render the water at the current state. Then we increment the water unit and do the same algorithm again, visualize it, then we increment the water unit, and on it goes until we find a minima. That's when we jump over to part 2. Yo, what's up, Ronnie Cax? Hey man, love your videos, appreciate it, thank you. Hopefully I will be able to release some new ones this year, this autumn. Okay, let's see. So first of all, I want to try, well, first of all, we're gonna do, actually, let's try it normally first. Oops. There we go. So we add water, it flows down there, finds a minima. So the spike is the minima. This is just how we chose to visualize it. Here we didn't find a minima, and that's when we get this loop, which is the wrong loop, or we don't want it to end like that. Although I wonder, okay, so I think this loop we're seeing here is because, let's see how it looks. Okay, we get into a wonder why though. There we find a minima. There we find a minima. This, like, it looks extremely rough already, but with some nice transitions and some actual water shader, I think this is gonna look beautiful. Definitely. I love this little edge we get here also. But yeah, okay, we get into a state like this. Okay, let's see. Affected points is just for visualizing stuff, but then we also use it, it's for visualizing here and visualizing here. Although Oh. That should be okay. Although I wonder, yesterday we had this in a stable state, except like we had it in a good place, but it only moved in one direction, and that we know why it did that. But currently, I don't know why we aren't able to set it into. Why we can't achieve the same result as yesterday. And we clear this one each iteration? Ooh. Water temporary. I don't think we actually clear it here. Okay, that's okay. I think we can also do this. I think we're gonna take this one and put it first here. Oops. So once again, affected points is just to properly be able to visualize this, because we want to update the position for every point that has been altered. And even though we don't add end to unvisited points, we have tried to add fluid to it. Ooh, maybe I know, by the way. But yeah, and then we're gonna change this one to, so if the fluid spread is bigger, no, that's still not true. Let me just run this one more time and see if I can figure out. So what we're seeing here is, that's beautiful. What we're seeing here works. The problem could also be that, yes, if so currently we are able to start multiple of these processes at the same time, and it's currently not thread safe. It's probably not going to be either. So it could have been that we just had two of these simulations running in parallel and one fucked up the data for the other one. This one I like. Although I wonder... Okay, so what happens here is that we dry up. Yeah. So the idea is also to, while we're running the initial, or while we're running the second iteration of the minima found algorithm, that's when we visually animate the water to flow out from the entry point. So if we add here, we will see water appearing down towards this point, and then we find the minima. But okay. Yeah, so this is the problem we get. We only have it flowing in one direction. And okay, so now we're back at the state just before I quit yesterday's stream. And let's see if I can remember. For this one, I actually like the specular highlight, even though we have... it's a little bit rough. We can probably improve the normal generation here eventually, but okay, let's see. So what I wonder is, let's see here. Let's add again. What do we have here? Water. I find it extremely weird. Let's see, I had it yesterday. What the hell was it? Yeah, I think it was calculate fluid spread. Oh, yeah. I think I know. Yes, it's the culprit is this one. So what we get basically is P spreads to its neighbors, and then when we start iterating the neighbors spreading to their neighbors, it actually spreads back to P and sets their water value to a smaller value, and it eventually dries up. The reason we don't get it, the reason we only get it in one direction is we get it in the negative x and negative z direction, which are the first points. So we're always going to choose the first ones, or we're always going to jump in that direction before we... It's always going to spread in that direction first. Okay, I'm pretty sure that's it. So what we would need is... we need some statement first here, which is something similar to if, let's see, false. Here we want something like if already visited. Continue. Right. It would be very nice if we could do it with something we already have. Fabic, sorry for the distraction, but you can remove the terrain fluid solver from... oh, you mean here, right? Yeah, definitely, but I like it explicit, you know? But I'm warming up to being more implicit, so yeah, maybe we will. But it is in the class, yeah, but this is like, this is my way of this is my way of explicitly stating that this one is a static variable. A static read-only. Much like, so this whole class is a static one. So always when you call on methods or... Yeah, no, it's a little bit weird. We will see about it later on. But, like, I just want to be... What is it? Like, when we call this class from outside the class, or when we call on anything in this class... but you're right, because we have this as well. Calculate spread amount. Calculate fluid spread amount. This one is a static method. but I don't write this one. So if I want to do the same thing everywhere, we should remove this one or add it here as well. Thinking C# naming convention for static read-only variables. We have it as read-only, but it's more like I wrote it this way because when I see it, I don't want it to be any questions as to where this variable stems from. Is it an argument or is it defined in the method? I want to know instantly when I see it that this is a static read-only dry constant. Okay, let me put it this way. It's the same as a lot of people like to. Now, a few things I do, or a lot of the things I do, are quite weird, and maybe I should move towards a more general way of doing it. But like, this is my way to tell myself that this is a static variable, as some people like to name their private variable with a underscore prefix, basically, which I've never done, but I'm starting to warm up to it. So as soon as you have a underline prefix, you know it's a member variable. But yeah. Something I should have done a while ago is, like, when I started programming C#, I should just have looked up the most popular style guide for it and just follow it without questioning it. But yeah. Okay, so this is what we want to do here, because we don't want to calculate fluid spread amount back and forth, basically. But so we could define a list that is visited points, and then we add visited points to it here. Also, it would look something like, let's try it. And then we do if visited points contains n, continue, and then we just need to add p to visited points as well. So we do although think. There's a lot of contain checks here. Contains, unvisited points contains. Nah, basically what we want to do is, fuck, let's see here. We calculate the fluid spread. That's basically the new fluid that this one will contain. And if fluid spread is bigger than n dot, we want to clean this one up as well. If fluid spread is bigger than n dot get value water temporary. If this one is true, that's when we want to set it. And we're going to set it in a much cleaner way. Right now we're going to set it by doing n dot set value terrain data type water temporary fluid spread. Okay, and then we also do if, yeah, then we want to check this one as well. If we do it like this, I don't think we will ever add two of the same points to unvisited points. Okay, so we calculate the fluid spread from P to N with a dry constant, and we want to do it in water temporary. This one I don't think we need to send in anymore. But then we can, so we pretty much calculate how much, what will be the new fluid value for N. And if that value is bigger than the one we already have in N, if so, we set N's value to be that value. And then we check if, I want to make it extremely clear what we're doing here. So terrain data type water temporary. So if water temporary is bigger than height, then we add it to unvisited points, because this basically means that it will be able to spread its water to its neighbors. And finally we need to add to this one, but we're gonna do it, we do this, and then we end by doing visited points. Or actually, fuck, we can't do it here, never mind. Okay, I know one cleaner way to do this eventually. One sec. We're gonna do visited points. Actually, if visited points does not contain P, should never happen. I don't think. But let's see if this works. Eventually, I think we might be able to just use this one. Maybe, we'll see. Although I wonder, the reason with this new, or with this altered implementation, the reason that we can actually go from P to N and then from N to P is because of the way we sort this one, I think. Or actually, is it? No, it's because of this one. Or actually, I'm just trying to figure out, by doing this, or no, by doing this, okay, I think we can do this. Can be removed by improving the check before n.set value. So it has to do this check right here. We could alter this one in such a way that we can't ever walk backwards, and we had it like that when we worked with fluid amount instead of fluid surface height. But now when we work with fluid height, it's a little bit different, because if we move downwards, I wonder. Okay, so this one is true when a neighbor gets more water than it previously had. Moving up. Fuck, I don't think we need this one actually, with only this change. I want to see what kind of result we get with this, and if we get a good result, I'm gonna try and remove the visited node check. Good. Beautiful. Yeah, this is how we want it to look. It's not super pretty, but with some noise method it might work. Okay, beautiful. Yeah, this result could be quite weird. So if here we get, okay, here we find this one, that's good. this one is gonna visually look pretty weird, I suppose. So let's say that the player starts pouring water here. We pour water like this. This is the minima we find, this one. But yeah, okay, so the water pretty much dries up while it's flowing down here. Does that make any sense? Or actually, yeah, it doesn't dry up. But we never find these minimas. So maybe, so right now we pretty much do a early exit. So if minima is found, we return true here. And if that one is true, we stop this while loop. But what we actually should be doing, like if we would have let the algorithm run its course, we would have found these minimas, or this one. Actually, we would have found all of these minimas and that minima. And then we could check which one of those is the lowest one or whatnot, or which one has the lowest height, and which one, and of those, which one is closest to the source of the water. So we would eventually get this minima. But that's like a tiny improvement. I wonder how weird it would actually be if we got this, if we played the game, we poured out water, we get this visualization, prettier of course, and the water actually starts filling up from this point instead of this point. It would be quite weird, I think. It was a newbie mistake of me to not foresee a use case where we actually find two minimas in the same small iteration. But then again, with a more dynamic terrain, I don't think I will be supporting brushes that looks like this. A case like this would be quite rare, but still, if I was playing this game and I didn't know how it was implemented, I would have assumed that we would start filling up from here, definitely. Definitely. But then again, yo, what's up, Pocket Mage? When making generic assets, it's always difficult to predict everything in one go. That is definitely true. In this case, however, this water fluid is pretty specific for my use case right now, as I want it to be. But yeah, this is... yeah. You always fail to predict every possible path. But like, this isn't a hard problem to solve, it's just that we don't want to exit too early here. We could what we probably should do is, let's see here. But actually, oh yeah. I mean, what we could do is we digress one step more, we add back the minimas list here, and at this point, let's see here. Yeah, okay, so what happens is something like this. Let's see here. We have this point, all of these points actually on this line here, and we have all of these points and some other points in the unvisited points nodes list, I mean, and we sort those. Actually, let's see here, unvisited points. The fuck? Order by height. In that case, we should be getting this one, but I don't know. Oh, okay, I get it. Yeah, okay, so this is a even more special case actually, because these points are what the fuck? Am I understanding this correct? Are you trying to make it so that the fluid flows from a high to a lowest point? Okay, so it's an algorithm for adding water to a terrain, given a set of rules which we have defined ourselves. So it's not supposed to be physically correct. And the algorithm has multiple steps. The first step, which this one is to find a point in the terrain where water can actually pool up, a so-called minima. and a minima is a point which is lower or equal to all its neighbors and at least has one neighbor that has a greater height than the point. And the only problem here is that, like, when I first look at this one, it seems like we find multiple such points. So we find such points here, and we find it here, but for some reason we picked this one when we would have picked this one. But I thought that, or I wonder, actually, okay, I know what's happening here. Yeah, I know what's happening here. So the fact is, we would always pick this one. So these points were not actually part of unvisited points, because if they were, we would have picked this one instead of this one. What happens here is that this terrain here is at the lowest possible point. The terrain cannot go any further down, nor can the water. So this is just part of how it's rendered. Okay, so it's nothing wrong with the algorithm or the minima we pick. It's just when we deform the water shader, this is how it visually looks. But it's a little bit weird, to be honest with you. I don't know. I guess it would look quite okay anyway. And actually, when we do the spread as well, when we do the flood fill, we're going to do it in a more circular way as well. It's going to be a little bit more costly to move to a diagonal point. So right now it costs as much moving to this point, from this point to move to this point, from this point to move to this point, and from this point to move to this point. So that I want to fix as well. But that's something we only want to do this reminds me of Minecraft. Water looks great. Thank you, appreciate it. And this, believe me, is just the beginning. We're gonna go crazy with this shit. So right now, this is pretty much just a 1-to-1 representation of the algorithm. So pretty much no shader is applied to this water. I think we can make it look pretty damn good in the end. Hopefully. I think a better representation would be with a more organic terrain flow, so like this one. If we start pouring water here, it will flow down to this point, and that's the point where we will start filling up the pool as well. I think okay, I think we're pretty much done with this one for now. We haven't added any timestamps or something like that, but I want to try one more thing. I want to see what happens if we skip this check and this check, because I would really like this part of the algorithm to work with as few variables as possible, especially lists. I hope, or I'm hoping that this check right here will make it so that we don't revisit points, even though we don't have a visited points list. Like this example right here is one that somewhat shows what I want to achieve with this fluid terraforming. Like if we did it actually, okay, this one right here. Oh, it actually took this path, but okay. So if we add water here, we find this minima, and then we're gonna start fill up this body or this pool here with water, with this one as the entry point, which means, like, depending on how much water we fill it up with, we will get water, we will get a high point of water here trickling down to this pool and trickling down to this pool. But if the player, on the other hand, decides to add water here, we will start filling up with water with this as a minima, which means that we won't get water trickling down from here to here, but rather this one will fill up until it overflows to this area. So, depending on which starting point the player chooses, the water might look extremely different, even though it's the same area he or she fills up. And I think that is a nice way to go about it. It means that the player has more control of where he or she wants, in what direction he or she wants rivers to flow and stuff like that. But we'll see. Okay, so let's try if this works on a flat one. So we do it like this. Yeah, we get the same result here. So that's great. We don't need visited points. That's beautiful. So it has to reevaluate the same area after a certain point. Basically, but the rules are gonna be a little bit different. So here it's pretty straightforward. We make the water always move in a in the cheapest direction, which is it's gonna do that later on as well. It's going to reevaluate the in some cases it might not be the same area. So for instance, in this example, the player starts pouring water here. We find this minima, and this is the area we will fill up. We won't, like when we have found this minima, we won't fill up the water more in this direction or this direction, and like we will only start filling up this area. So if the player chooses to quit adding fluid after we have got a surface height up to this point, maybe, then this water will dry up. So it's going to reevaluate the same area, but it's going to do it a little bit different. In some cases it's going to reevaluate the same area, but it's going to do it with a different goal in mind and with some adjusted rules. Oops. I think this looks great. So let's say, for instance, that the player runs to this point, pulls up the bucket of water or whatever it will be, starts pouring water here. We will get a flow down to... We will visualize a flow like this down to this point. We will keep this visualization, but we will start increasing the water here. So the fluid surface height of this area will grow and grow and grow until the player stops adding water. So if we add water here, we start by evaluating this point, and I think we are evaluating up to this area. But then when we actually start adding the fluid, we will start from here. So we have an overlap, that's true. Like, let's say that the player stops adding water at this height. Then we will have evaluated these points in this square. So these points have been evaluated twice. These has only been once, and these have only been evaluated once. Okay. Okay, I think this is a pretty short and... Let's see here, what do we have? This. It's a pretty short and compact way of doing this part, especially since this one also includes, apart from the algorithm itself, it also includes a lot of lines that are only here to help us visualize it down the road. Okay, so the question is, are we ready to move? So at this point we're pretty much done with this-ish. I wonder if I want to do this now or wait. We're probably going to wait with it for now. But now we want to do this one. So we're going to have a new while. What the fuck? Okay, let's see. I'm gonna have to rewrite this one a tiny bit. So we're gonna do find reachable minima, private static. What do we want to return here? I think we basically want to return new final fluid amount. Fluid amount. Yeah, so we're gonna put do a private static int or actually, now when I think about it, it's going to be way easier to implement the next algorithm and test it if we actually add the part about being able to end adding water. So when we start adding water, right now we just do a action and then we can run around with the character and so on, but I want to make it into a process. So when we click the button, we start adding water, and when we click the button again, we stop adding water. Action Terraform. Yeah, the problem might be how this one is built up. Start coroutine Terraform. I don't know if this is a pivot I want to do today, but okay, so if we take a look at the action system we have implemented here, I've been thinking about this action Terraform. It has been working quite good during the testing so far. But in the game eventually, I wonder if I want to redo this one and make it, rename it to something like action item use or something of that sort, and let the Terraform and let the Terraform logic be moved from an action or from the actual action to the item in itself. Because using the shovel as opposed to the bucket of water will be quite different. But I think that is, I don't think I'm ready to do that change today. So the question instead is, can we just do a quick fix, making this into a process depending on the Terraform brush. So if we start Terraform brush, what do we have? Brush operation. We have terrain data type here. So what I'm thinking is that we could do first, last increment, mesh dependent. Yeah, for now I guess we could do something like yeah, okay. We have try stop processing here. If we do it ugly and we do brush, I wonder what would happen if we just do else. And here we do what the hell, we do this, put this one in here. So if we're currently not terraforming water, we try and stop the process from the get-go, which will eventually get us to this one. We stop the coroutine and whatnot. So if we have this one right here, I think if we add water, it won't quit the process, but we will have to do it manually, or I hope that's what's happening. And I think that's great. The only problem... yeah, we're gonna have to secure this later down the road, definitely, because this is gonna be quite messy. So when we start terraforming with water, we actually start multiple tasks, or we do a lot of asynchronous stuff. And if we cancel the process in the middle of it, it's going to be a lot of work to stop the correct tasks and stuff like this. Let's just see if this works first of all. So if we do water here and I add... yeah, now we have cancel terraforming here. Okay, that's good, but I think we can still move around. I don't want that to happen, so we're gonna do action terraform, start processing, stop processing. So we're gonna do what the hell? Did we put entity here? What is the other part we want to enable movement? Align with transform, no. And then we want to do some animation and things like that, but we're quite some time away from that. But definitely want to enable it again eventually. Something like that. So if we add water here now, I can't move around unless I do click E again, and that's when we can move. Okay, great, that's a first step at least. And the idea, let's see here. I want to cancel animations as well, but yeah, that's no big deal. Although I noticed that, or does it? Yeah, this one becomes higher and higher. I wonder why though. Water 15. Yeah, I want to double check that one. I don't want it to become or grow in size, not during the first part of the algorithm, that is. So it's when we put water here. Get value. If height is bigger than water, we do height plus fluid amount, otherwise we do water plus fluid amount. Water. But then we move data water previous to water, so we should reset it as it was. Fuck. Yeah, we don't want fluid amount here. We want terrain fluid solver. Yeah, what's up, Calvino? Hope you had a great summer, man. And yes, indeed. That's usually how it sounds during a troubleshooting session. Here we want fluid unit. It's just like when I visualize how I want this water to look, or how I want the animations and the visuals to look when we add water. When we just try and find a minima, I want it to be a very thin dripple of water. So let's just see here if we have the same problem. Yeah, now we have the same height, and we just spread it. And we find that one. Okay, beautiful. I mean, the algorithm, when we start searching for an area this big, it starts slowing down, which is to be expected. We can optimize it in one way because we re-evaluate the same area multiple times in here. That's true. But yeah, depending on the time, it doesn't really matter just yet. And something to keep in mind as well is that we have a 2-second delay here. Calvino, yeah, first week back to work after 3 weeks vacation. Oh, same here actually. Already tired of work. Okay, that sucks, man. Spent 1 week in Greece in a villa with infinity pool. Sounds nice. How was your vacation? It was nice, but I'm just trying to I'm still adjusting to the fact that when you have a child, a vacation isn't really exactly how it used to be, if you know what I mean. It's not bad, it's just different. It's less of charging your batteries and more of just doing shit. But yeah, it was nice. It was nice. Spent it in Sweden this year, traveling to family and stuff like that. I wonder, okay, so now the big question here, the big problem here is that we want to be able to exit this method in a nice way, and it's not like we can cancel it and call it quits. We also need to do stuff when we exit this method. We need to calculate a lot of stuff, how it looks right now. Yeah, basically this algorithm tries to calculate a stable state, and when we exit it or when we cancel it, we want to look up which is the latest acceptable stable state and change some data based on that information. So yeah. Calvino, me and my wife are actually expecting. Damn, nice, congratulations. Exciting times ahead. How far along, if I might ask? Damn, exciting. Exciting. So it's expected to come around March. Oh, nice. I think that's a really good month. Or that is what I would aim for future children. Going on walks with the warmer weather and stuff like that. As opposed to November, which was my case, it was interesting. And I think it's maybe, I don't know, there's some months on the around January, I think, where you have to be extra careful because of some virus, but I'm sure you will learn all about that. Oh yeah, not being at the top of your pregnancy during summer is also a good thing, definitely. Okay, so what can we do about this one? So it's here. The good thing is, or the somewhat good thing is, fuck. Yeah, right now this one is structured as a static class. I'm wondering, I've always been on the edge between having it as a static class and having it as a singleton, because I think if we're gonna be able to exit this one in a nice way, we need to store some variables within it that can change. And actually, this would be even nicer if we would move this functionality to an item, so to the bucket of water, then it will all be fixed for us. So maybe that is the approach we're gonna take. Calvino, do I also have to program a game when I get my kid? Dad Programmers Club. Yes, it's a must. It's a must. At least a half-speed game jam. So yeah, I think it feels a little bit too early to start thinking about this already, but it's good to have a plan, definitely. But I think we're gonna move this logic into an item instead. Yeah, we're gonna do some reworking when it comes to the Terraform items. So the idea has always been, when the player picks up the shovel, he or she can alter terrain or dig in terrain. Then we have a bag of dirt which can alter terrain or add height to terrain. So shovel can remove height from terrain, bag of dirt can add height to the terrain. Maybe I will make the shovel do that as well, I don't know. But then we're gonna have a bag of grass that can add foliage to the terrain. We're gonna have seed bags that can add trees and whatnot, and then we're gonna have a bucket of water. I think it's a little bit like a bucket with infinite amount of water. It's much like a cartoon. I like it. And if we move a lot of these Terraform logics to these items instead, I think it will work out for the better. But let's see here. For now, we're just gonna keep it as a static class, and we're gonna do something we shouldn't do when it is a static class, but I think, or actually we can't do. Yeah, let's make it into a singleton real quick, because we want it to have an internal state, and the internal state is going to store stuff that we can use to exit the process prematurely. Yeah. And then we just remove this, this. Do we actually have this much? Oh, come on. Now let's do static. And I'm gonna have to do it like this. Actually, this one and this one. Fuck, I think I want... Oh, we don't even use these anymore, I don't think. But we might need them eventually. Okay, so now we have a singleton instead of a static class. So we can hopefully do some internal states. And what we're going to do first of all is we're going to add a... We're going to add a private I want to name it solving or is solving, but that is a little bit weird. We could go with is running and add fluid async. We're gonna double check this, but I think I want to make this private and we want to call the async call from in here. Probably. But for now, let's do if is running. Return. True. Yeah, and we're probably, so if we take a look at, that is true for this case. So if we take a look at this part right here, or maximum water is reached. I haven't really decided how I want this to play out gameplay wise, but let's assume that the player adds water to a point and we increase and increase and increase the water until we reach the maximum amount of water we can add. Do I want the player to be able to keep adding water to that place, so we just play the animation over and over and over, but we have no change in water surface height. Like, I think it might confuse the player a bit, like why aren't we getting more water? But depending on this limit, it might be acceptable. So it's a question of like how the gameplay will play out, how clear will it be, and depending on that decision, we can either have this task only be able to be exited from player input, or it can actually exit itself. And if we add that second option, that this task can reach an end or an exit point by itself, that is going to make it a little bit more complicated. Calvino, if I may ask, is this terrain editing gameplay a gameplay feature? Yes it is. Like, it's actually going to be part of the core gameplay, so it will play a very big part. Like, the player will be given a plot of land and cultivate it and change it exactly how the player wants it to look. Add hills, add rivers, add lakes, and so on. And depending on all of these things, different creatures wants to move into the garden. So for instance, we might, in the game, this might not be the best example, but there might exist a creature that like high places, so hills, and we during the game running, we always keep track of a lot of statistics of the garden, like how many points of the terrain are above this height, and so on and so on. So we will see when a player has a lot of the garden is above a certain height, we will trigger an event that makes it such that creature that likes to live in high places will come and visit the garden. And yeah, my main point being that yes, this is a very big part of the gameplay. Yes, exactly. That's a perfect way to put it. I wish I could put it that way. So the terrain has a lot of metadata, and depending on that data, different creatures like it. Yes. So for instance, a better example would probably be water creatures. We will have some creatures that only live in water, and if the player doesn't have any lakes or rivers in their garden, that particular creature will never come and visit and eventually move in. And the idea, this might be like an optimistic, I don't think it's an optimistic deadline, but my first deadline I've put up now is that at the beginning of next year, I want to be able to put out almost a vertical slice of the garden terraforming. So I want to put out a playable demo, or push out to some people the terraforming part of the game, just to get a feel if it's fun to alter your garden and stuff like that. Yes, we will have trees, bushes, flowers, everything like that as well. I will, Calvino, I will. Hopefully, if nothing happens, if nothing big happens, I will have a demo out early next year. That's the idea. And honestly, like the part we're sitting with right now, everything that has to do with water and water terraforming has like when I specified this task, I knew that this is gonna be the hardest part to get right. But I think we're getting close to a good result, a result I expected. Yeah, so I'm being optimistic. What I'm trying to say is, when we have this water in place, I think a lot of the other stuff is going to be much quicker. Like adding bushes to the game is going to be way easier than actually developing a fluid solver that can handle river and stuff like that. So yeah, early next year. Okay, so as to this one, this means that we can't start 2 of these at the same time, and I think that's beautiful. For now, let's do it like this. Is running is equal to false here, and we can just try it, see if we have locked it accordingly. Oh yeah. So here we just want to do, what did I call it, instance, or I think we want to do it like that. Terrain fluid solver. Oh yeah, public static terrain fluid solver instance. There we go. And we can see here that the original fluid solver we had during the experimental phase was actually a singleton, so I think this is a good choice. Yep. So the idea now is that, let's see, if I do this and try to add a new one, it doesn't work. We actually lock our player, but that's okay for now. Okay. So, I think we can. Yeah, let's do this. Add fluid async. Public. Best case, I would like to have something like this: async task stop add fluid async. Something like this. And what I would like to do here is task bool, and then if we do yo, what's up Mimi, hello Robin, what we cooking today? We're still doing the fluid simulation, but we're tying it together with gameplay basically. we're adjusting it to better run with the gameplay idea we have. So stop add fluid async. What I would like to be doing here is, I wonder if we can do if is running, or if it's not running, we just return true. If it is running, on the other hand, we want to do, for now we want to do clear data water. We're going to add a lot of logic here eventually, but first of all we just want to clear whatever we have in water, and we want to do these two things. I think we're going to do it like this for now. Affected points, yeah, this is running private list terrain fluid point affected points. One thing here. First of all, I just have to mention that this line right here, I'm a tiny bit nervous about this one. This is not really something we can do in a separate thread, because we're actually altering the mesh itself, and I'm a tiny bit afraid if we might see a big FPS drop from this one. We could make this be done on a separate thread, however, and just do this one on the main thread. So what we have here basically is we put whatever we have in mesh data, we put it in mesh. That should be pretty quick, I hope. I think so. And then we also do update mesh, recalculate bounds. We could, yeah, this one we could probably speed up as well. We could do this one ourselves on a separate thread. So it's pretty much only this one we can't do anything about speed wise. Hopefully it's not too bad. It's good to keep in mind, however. But so back to this one. Looks a little bit weird here right now with never return false, but the idea is stop add fluid async. So basically what we want to do here is we want to, so the stop adding fluid is triggered by player input, And I don't want to change the character animations or anything like that, or make the player be able to control. Or actually, maybe that's okay. Yes, so as soon as the player stops adding water, we do all of this. We do it on a separate thread. We can make this on a separate thread as well. Or are we already? No, we aren't. But the idea is that we do most of the heavy work here on a secondary thread. As soon as the player clicks the button, however, he or she can start run around again. And this one will run in the background, alter the water in such a way, like bring it back to its stable state. But the player cannot add more water until this one has reached its stable state. So we're just going to make this into a task. We're just going to do return here, and the last thing we're going to do is running false. Okay, so with the current implementation, what will happen? We will find a minima, then we will stop running this one. We will visualize the minima until we cancel the process. Yeah. So we will get to an end state like this. We can't move the character. We can move the camera though, that's good. And we will visualize this state until I press E, I would have hoped. Oh. Okay, so why not? Yeah, because clear data water. Yes, because we don't call this one just yet. So terrain patch, alter terrain data. I guess we're gonna add a public void cancel alter terrain data. For now, we're just going to do a check like this. And then we jump to action terraform. So stop processing here. We enable movement, enable physics, but first of all I also want to do and later on we're also going to make the height changes be applied on a secondary thread as well. But for now let's just do We're gonna do it like this. I'm wondering. Okay, actually, depending on how we implement this one right here, we might be able, it might be, or it will be, easy to cancel it from the fluid simulation later on as well, I think. But it's going to be sort of a polling situation, or we could do it as a event, I don't know. The options we have are to store this one as a class member, then we can stop it from outside of the this coroutine, or we could make this coroutine depend on a boolean. Yeah, I don't know how I want to do this. Derek, hey, I was wondering if you had time to talk about your new edge detection for outlines. I can definitely show it, but I don't know if I have that much time right now to go into depth of how it's done. I can bring up the shader here. And go down to it's pretty simple in its bare bones, so to speak. We have a lot of complicated stuff here to make the outlines appear beautiful from a distance, be affected by fog, alpha value and whatnot. But the filter itself is basically just this one. So we can take the normals, for instance, or maybe the depth would be the simplest one. So we have a kernel. Let's say that it's 3 times 3. So what we do then is that we sample all of those values, and we sample the depth, and if this depth is greater than pixel depth max, one sec. Yeah, this one is. So for each pixel in the kernel, we do a compare function, and what we basically do here is we do a thresholding. So this one either returns 1 or 0. So for each pixel we do thresholding to check that it is between 2 different values. If it is, we return 1. If it's not, we return 0. And we increment all of these. So in the end, we divide this one by kernel elements, and then we smooth step. So how can I explain this in better mathematical terms? For each pixel in the kernel, we pretty much check if it's within a value. We count how many pixels in the kernel that are within these values, and based on that we do a smooth step to figure out how much of an edge this should be. So it's pretty much we take a point to figure out if that one is an outline or not. We check how many of its neighbors that are within an acceptable value, like, or how different are these compared to the center value, and if more than X number of neighbors are above that value, then it's an outline. Does it make any sense what I'm saying? So for instance, let's say that for a neighbor to be able to contribute to if a pixel should be an outline or not, it should have a depth value that is X amount different from the center pixel. And if we have multiple such, or based on how many such neighbors we have, we add outlines. So let me just paint it real quick. So let's say that we have this kernel, we have our depth, or we read the depth values for all of these pixels, and then we compare, let's call this one D1, D2, and so on. So then we compare D with D1 if D, let's see here, if abs of D minus D1 is bigger than some threshold, then we have 1, or more like then this one will count towards if this is an outline or not. And then we do it for all the neighbors, so we might get something like this. So all of these have the difference between these depth values and this one is big enough so that they contribute to if this one is an outline or not. These do not. And then we have maybe a final check, that is if the accumulated if the number of elements in the kernel, I don't know, D is bigger than some value, then this one is an outline. Hope it makes sense. It's extremely simple at its core. But then eventually we also we do some more complicated stuff here to actually decide the alpha of the outline from depth. So yeah. Thanks for the explanation. Yeah, it probably wasn't the best of explanations. I am going to make a video about it where I can hopefully explain it in a better way when I've had some time to think. But as soon as I post a video about it, yes, we're gonna update the GitHub repository, or we're actually going to we're gonna update the GitHub repository in such a way that one can choose different kernel functions for figuring out if something is an outline or not. But yeah, like just message me on Discord, and when I have the time, I can write a short description of what we actually do. Hopefully one that is easier to understand than what I just did right now. Mema, this shader and the water system in the video would be very interesting. Yes, like I have a lot of videos in the pipeline. Hopefully I will have some time to finally make them. But I think definitely like the terrain system is going to be one great video, I think. The water is also going to be extremely interesting video. Maybe the water more than anything else, to be honest. But yeah, like this simple approach here that actually produces good result, I think I streamed it at the beginning of this year. And it came from the fact that we noticed some imperfections with using Robert's Cross or Sobel, and I just tried to get around those imperfections by adding more conditional statements to the kernel, and eventually we arrived at this result here. So I think we're using a 3x3 kernel. I don't think you only want to make it bigger if you want bigger outlines. We can check. Do we have kernel size 1 here. Yeah, and 1 here is that we move 1 and 1 1 pixel in every direction. Well, don't we have a material for this one? outlines material. Yeah, we use a kernel size of 1. Like, I think this is very interesting, but so if we take Robert's cross, for instance, the only pixels you care about are this one, and this one, and this one, given this one and a distance of 1 pixel. And what you do is you take this one minus this one and the absolute of it, and you take D1, 2, 3, 4, 5, 6, 7, 8, or we can call this one 9. Something like this, right? And then you compare if it's bigger than threshold. One sec. Fuck, it's been a while. You take this one minus this one plus this one minus this one. Something like that. But okay, the bottom line is you do the Robert's cross and then you compare it to the threshold. This new method is we just take this pixel and compare it, this pixel minus this one, compare it to the threshold, this pixel compared to this one, or minus this one compared to the threshold, and then we do it for each pixel, and then we use that result. An extra comparison, pretty much. Let me contemplate this and see if I can do a write-up that is more straightforward and easy to understand. But okay, back to the water. Derek, and you used this setup to sample both depth and normal, right? Yes. And we actually sample the alpha channel as well, which is segments. So we can see it here. And this one is also very interesting. We noticed that let's see, where do we have comparison? So this is where we do it with depth. This is where we do it with normals and segments. And you can see here that we actually do it per color channel when it comes to normals. So we don't take the full normal, we split it up into RGB and do the comparison per channel. And then down here we divide by kernel elements, and if a great amount of neighboring pixels had a big difference, then we put it as a normal. So in my solution currently we use 5 values to figure out if it should be a normal outline or not. Normal R, normal G, normal B, alpha value of the texture, and depth. Okay, so actually I think we're gonna do it like this for now. Let's see, do we have stop processing? I think we can just do fluid or terrain fluid solver instance dot stop add fluid async. That's all we need to do. like I can show one last thing with the normals as well. So this or the outlines, this outline system isn't, I think it can be improved a bit more, but if we zoom in here, you can see some artifacts from it here. Like this, for instance, because we do it in an alpha way as well. The good thing with this approach, or this new filter as well, is with the implementation we have, we actually get a anti-aliasing. We get anti-aliased outlines from the algorithm. But that also means that we get, like, this is a point where the pixel that should be an outline or not is, it has a few neighbors that has, or a few of its neighbors has a big difference of some value, but not big enough to make it a pure black outline, but rather a black outline with 0.5 alpha value. And that is great in this case, for instance. But yeah, it's still a work in progress. But I definitely think we got a way better result than for the Robert's Cross. That's for sure. Okay, let's see, water. So if we add water here, we get something like this. We can't move the character. We visualize this one at all times. And if we cancel, we remove it. Derek, I can't wait to see what you do with the water shader. Neither can I. I hope. I have big dreams for the water shader. I think it's gonna look amazing. One thing that I'm very much looking forward to is the fact that we have a shader that can distort the outlines. So let's say that the player stands in water and the water is transparent. Let's see if we can add here. Or I'm looking very much forward to implement this visuals. Okay, so the character didn't stand in the water here. But let's say let's say that the water is obscuring the character like this. And we make the water shader transparent, we will actually be able to distort the outlines that is obscured by the water. So because like when you look in water, the light gets distorted, and we want to visualize that. So depending on the flow of the water, the character will be distorted. What I'm trying to say is that the outlines will also be distorted. So I think it's going to look amazing. Hopefully. Okay, but this works very good. I think we can move on to the second step here now. Or one more thing, actually. I think that oops I think that I want to add, or I want to introduce an additional cost for moving diagonal here, because I don't want this to search in a square. I want it to search in a semicircle. The point sticking up from the water is... Can we exit this one? Yes. Okay. Yes. Okay, we need to fix that. But the point sticking up from the water is... it's just a quick way to visualize the minima for us. So when we run this algorithm, we know that this point right here is the selected minima. I think it's... can I jump up here? Have to clean that one up as well, but whatever. I think it's a little bit more visually... we can do it here. So what it represents is that... Wish I could run here, but this point that sticks up is the lowest point. It doesn't have any neighbor that is lower than it, and it has at least one neighbor that is greater than it in height. Yo, what's up, Robert Pattinson? But okay, so one thing I notice now is we don't properly exit the task. So if we... I think it's still running right now, is it? If we do... let's see. Yeah, I think we have a race condition. That's what we have. Yes, there we go. So when we quit the algorithm, we actually don't quit it because when we quit this one, our task, we still have a task that is running here. So I wonder, so for instance, let's say that we do, we're in this method, we call quit, this one still returns, right? Or this one keeps going. So we're gonna have to save a reference to the task and exit it. Robert Pattinson, oh yeah, the Rust God. You know there are no race conditions in Rust, just saying. Is that true? How the fuck did they manage that? Interesting. I might want to read up on that one. C# task. So basically, can we get some... okay, yeah, I definitely want this one up as well. But there we go. Let's take a look at some examples. Task, finished task. Yeah, we probably want to do this, right? Yeah, I think so. Let's see, what do we have? I think our tasks... Yeah, so here we want to do... We want to add a task here. So for every method call we call here, we want to alter it so that they return task and whatever they are supposed to return. So we can reference that task later on. They don't allow you to use memory in a way you get race conditions. I'm very interested in that. But what I want to take a look at first of all is the task class or task T class. And what do we have here? Completed task. Continue with. Damn, I think this is extremely powerful. Dispose. Ooh. Whoa, cancellation token. You can do some real nice stuff here. But I was hoping for... Just cancel. Oh, yeah, okay, yeah. So we need a cancellation token, and that's the one we call cancel on, which will cancel the task, which will throw an exception. And I'm not famous for handling exceptions. Cancellation token. Do we actually have to check this one at all times? That is pretty rough. Ah. Yeah, exactly. Okay, so the only... So if we cancel it with a cancellation token, we get operation cancel exception, and we also get a task status state. Not sure if that's something we care about. Run to completion. Hmm. Hmm. Ooh, how do I want to handle this? This task. Ah, fuck. Hmm. I wonder. How do I actually want the cancel flow to work? What I'm wondering is, yeah, let's say that we run this one. This one runs. And if we cancel it and it's currently on this state, do I want it to stop here? So not continue with this? Or do I want it to be able to continue with this, and stop here? So stop after this. Do I want the iteration to complete, or do I want to be able to exit the iteration midway through? I'm thinking midway through, because the scenario is this. The player starts pouring out water at a position, and we're gonna increase the water surface iteratively, step by step by step. When the player is happy with the height, he or she cancels. So we don't want the current one to finish. But this makes it extremely, or way more complicated. Because, okay, this one just this one alters mesh data. This one alters terrain data. This one alters terrain data. But. Yes. Yes. So this one, if we cancel this one in game, we will actually get no water added, which is good. So the last thing, if we cancel it up here, the last thing that would have happened is, but then again, the terrain data is a non-issue, because if we let this one run through, we will always have whatever we had previously in the water will be the new water. So that is good. But my biggest issue is this one. But listen to this. I don't know how clean or dangerous this is, but if we have a task reference here, so we always know which current task is running. I can't do that. Yeah, okay. Maybe. I was thinking about... I think we can do it like this. So we have a task variable here. When we start this task, we set... So whatever task is currently running, we set to this member task variable. And whenever we do stop add fluid async here, before we do anything here, we do await current task. So that means that whatever task we're working with here will run to completion before we stop it. So this task, for instance, we will let it run to completion. It will alter the fluid mesh. When it has altered it, but then again, then we're gonna have to do it with a cancellation token, because otherwise this one will continue running here, because this one itself is a task. Maybe I'll be back in a bit. Have fun, gang. Appreciate it. Appreciate it. Yeah, but I haven't done myself any favors by... so pretty early on I constrained the amount of data we can allocate for this fluid solver, which means that we do a lot of swapping. We do a lot of this stuff. We move data from one place to another place. And this complicates when and where to exit the tasks, because we want to know what data is where and so on. Find reachable minima. But the endpoint is... I'm thinking that we might want to pack this whole thing up into one task. I don't even know. Yeah, I think we can pack this into one task. This one we get rid of. No, we don't. Yeah, we need to redefine the order of this to make it easier to have entry and exit points, pretty much. I'm Mysel, thank you for the follow, appreciate it. So what I mean here is every iteration of this algorithm, or the flow of this one, are gonna have natural exit points. So for instance, I would say that here, this right here is a natural exit point. Because we have calculated something in water temporary, we have moved it to water, and we have water previous. We have updated the mesh, both the data and the mesh. So exiting here is a beautiful way to do it. Or a beautiful place to exit. But then again, we have, I think it's pretty certain that we need to let the current task run its course, whatever task it is. But then again, Mysel are my favorite part of game development, staring at the code. I don't know if you're sarcastic or not, but I actually enjoy it most of the time. So. I think we need to define a few things here. Or write down some notes. Okay, the different task steps. So we can go add fluid async. What do we have? So we have setup. This one moves water to water previous. I think that's all it does. 2, find minima, basically. Find minima while loop. This one find reachable minima. What do we do here? Clear water temporary. Alter water temporary. Yeah, that's what it does down here as well. And then alter water. That's what we do here, set value. And we do it here as well. But then it also recalculate mesh data, update mesh, delay, and then we do water previous to water. That's what it does. And so setup here, I'm okay with this one. Let's see. Yeah, quitting here is okay because, okay, we clear data here. Basically what we want to do here eventually is we want to move data, terrain data. That's not really what we want to do. Let's clear it for now. Hugo, thank you for the follow, appreciate it. And back to as well, thank you. The problem here is that we want to exit this heavy computational task by user input, and we have to make sure that no matter when we exit it, because it can happen at any time, we need to make sure that we leave it in a stable state that we can represent. And I think it's as easy as doing, let's see here. I think it's easy. I think it's easy because when we exit it, we're gonna finalize the water data, and we're going to update the affected points or recalculate the mesh data, and we're going to do it based on water. And we're also going to update the fluid mesh. So whatever state we're in inside of here when we exit the task, it's okay when it comes to the fluid mesh and the mesh data, because we're gonna fix it, or we're gonna redo it. The only important part, or the most important part, is that the data we have in water is of the stable state. But I'm just gonna turn on my headphones 1 sec. Let's see here, what was I going to say? Yes, like when we stop fluid async here, we're gonna do it based on some variables. So if we skip it during this, we're not gonna add any water to the terrain. If we skip it during part 2, we're gonna calculate a stable state given whatever part 2, given the result of part 2. So actually, water here, the final state of the water data will be calculated here. I think. we will see. Back to 3D games are scary. I've been working with 3D games for, what is it, 6 years now, something like that, and I still think they are scary. So I agree. That extra dimension. Fuck it. One important part is that, like, when we move water to water previous, this one, we always want this one to be the state the water was before we started altering it. Because in the water shader, we're always going to interpolate between water previous and water given some timestamps. So I think the first thing we want to do here eventually as well is environment, controller, terrain, move data, terrain data type, water, to terrain data type, water previous, to do calculate new stable water state based on exit parameters. Back to, I'm just doing a 2D game at the moment since I hate 3D modeling and animations. Yeah, that's also something that is extremely tedious with 3D. But how's the 2D game making going? And I have to mention as well, like, the reason I went 3D was, or one of the reasons were that I didn't really want to make sprite sheets. I thought doing them was extremely tedious. But then I learned 3D modeling and rigging and animations and ate it up. Okay, so given the introduction of this, it's also important I think it's okay. The cool thing with this, I would say, is that stop add fluid async will actually be this part. So add fluid async, here we just add, or here we just calculate a lot of variables that will be used to specify the stable state, and it's first when we exit this task that we calculate the stable state. Ooh, I think this might work out, so I think that's a good so as long as we do think we can decide when and where we set the parameters to the stable state calculation, and if we do that in a nice way, we can exit after each iteration. Back to my game is sort of a graphical user interface game, kind of like Hearthstone. And I'm at the point where I got the core mechanics in, and now I need to be creative for creating the skills, which I thought would be easier than it is. Ooh, been there. I'm a big fan of graphical user interface kind of games, so like card games and the like. But a lot of card games actually have a lot of visual effects and stuff like that. Oh, I fucking love EU4. Incredibly excited for EU5. Football Manager as well. Been a while since I played it though. Yeah, I'm dreading making animations. Sometimes it can be incredibly fun, but I get what you mean. And Robert Pattinson, EU5 will be trash, trust me. I'm gonna decide to not trust you, even though I feel the same. Okay, what I think I'm gonna do here is we're gonna let this one run its course. So if we call exit, if we cancel this one, we're gonna let this one run, this one run, this one run, this one run, this one, blah, 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 blah. So we're gonna run to here, and then we're going to continue with this one, which means I'm thinking of doing it like March of Eagles to when? I don't know what that is. Ooh. Is March of Eagles 1 good? Is this any good? The fuck is this? Looks like... What the hell? Oh, okay, so it's extremely similar to EU4, but just in a different time period. And okay, so okay. First I was like, is this legal? Is making a ripoff like this legal? But yeah, okay, that makes sense. Same studio, right? Okay, so this one we can definitely let it run its course. But I'm thinking of just doing something like this, honestly. Introducing a new boolean. Yeah, we're gonna make this one be called... Yeah, we're gonna go with a cancellation token, I'm pretty sure. Handle the exception. So this one is going to trigger this one is going to be a task that is run in here. We're going to start it in here as well. At certain points, so here and at some other point, we're going to check the cancel token. And that will pretty much be it, I think. So private async task add fluid async, public void add fluid, terrain patch, terrain patch start, int x start, int y start. And we're going to do if is running return. Let's put it here. Is running is equal to true. And then I guess task.run add fluid async. Terrain patch start, x start, y start. And then we're eventually going to add a cancellation token to this one as well. And I wonder, let's take a look at it, how it looks. Task cancellation token source. token here. Then we run, we add a token here. Why do we want CT? Oh. Throw if what the fuck? Oh, I think we can make this beautifully. The hell? It's just have so everything. We don't need a separate method for this. Or we do, but the only thing we do here is that we set the we call this one. And then when we handle the exception within this one, that's when we exit the fluid. Ooh, I think this can be real nice. But my question is if yes, we can put this if right around here, I think. Or can we? Yeah, I think so. Okay, this might turn out nicer than I thought it would. Yo, what's up, Cooler SK? Hopefully we won't throw any code around, but an exception, I think. There's no way around it. So let's see here. Cancellation token source. Why do we need to do we need this one? Okay, token. What the fuck? Why? Why? Is this just to shorten this? Couldn't we just do token source 2 dot token dot throw if cancellation requested? Right? Ryan Gosling, thank you for the follow, appreciate it. What the hell? Yeah, is this just to make this shorter, basically? CT. Looks that way, right? Yo, what's up, Fabic? They changed because they cached it because they use it in a few parts. Yeah. What I wonder. Is this one reusable? Is this one reusable? Or is it a one-time use sort of thing? Cancel. dispose. Try reset. Hell yeah. Why can it fail though? Oh. Oh. Okay, so try reset. Oh, what the fuck? So we can only use this one. Okay, so if we call try reset. Okay. Okay. So I should be able to do token source. So try a wait task. So can we do, I'm a little bit, we should be able to do this, right? Try and then we do I don't know. I don't even know if we want to do anything on the catch. I don't know if we want to do anything on the catch. Yo, what's up, Puka? I need to stop drinking energy drinks. Me too. Me too. Calvino Nocco for life. I like to vary myself a bit, but Nocco is definitely nice. Or my daily special, 2 to 3 cups of coffee and pre-workout before the gym. Yeah, actually, I'm going into a period now where I wanna quit coffee and energy drinks and replace them with BCAA that contains caffeine, With crack. Yeah, with some Concerta or Adderall. No, but because I want to force myself to drink way more water as well. And if I just take 1 scoop of BCAA and mix it up with like 2 liters of water and drink that throughout the day. But I don't know. Puka, pre-workout almost killed me. We used to drink it all day long when I worked as a cook. Oh, fuck, man. I've heard people who work in kitchen, substance abuse is pretty spread in most kitchens. But yeah, pre-workout or some of the more intense ones, they really scare me. I hate that. I don't remember what the name of that. Within pre-workout you have something that makes your whole skin itch, basically. I don't remember what it's called, but fuck, I hate it. That's the best feeling. I got to freak the fuck out, man. It becomes toxic real soon. It still feels like it's not too bad of a habit. I mean, like the kitchen environment can be extremely stressful, or so I've heard. So only going to pre-workouts is still kind of acceptable. But when you start smoking crack on the backside, that's when you know you fucked up. Okay, so what do we say to catching exceptions? We hate it, right? So I'm thinking of just going try finally. Am I insane for doing that? Jacked PVO. Is it not legal in Sweden anymore? I also... the name of all these pre-workouts. What the fuck? Jacked. Psychotic. Kill it. Get the fuck out. Butcher. I remember Butcher. Okay, that doesn't sound too good, Calvino. Also, it's a comedian here in Sweden which likes to tell a story where he purchased some pre-workout from some store here in Sweden, and it made him feel like invincible, like he loved it. And when he finally ran out and were to purchase more, he saw that it was cancelled because it actually contained amphetamines. So yeah. I don't do pre-workout anymore. I could probably have been. Actually, for now, I'm just gonna go Unity engine fluid solver cancelled. Puka, one guy used to have this tub with pre-workout mixed with crushed paracetamol. What the oh, dude. Yeah, some people, they don't give two shits about what they put in the bodies. I wonder what his liver felt like. Calvino, by the way, do you go to the gym? I actually One more thing with being a parent, you try to cut corners everywhere you can. So you analyze your time during the day and see where you can cut out some time. And going to the gym comes with such a big overhead, especially when you work from home. Like, you have the travel to the gym, do your gym workout, and then travel home from gym. And I decided to cut out the traveling part. So these days I just I work out from home, bought some dumbbells, and I also run a few times. And sometimes when I run, I also run to the outside gym in the park and do some calisthenics. But that's pretty much it. But do I miss working out with, like, doing proper squats and deadlifts? I miss it. Sometimes I miss it a lot. Yeah, exactly. So like when you have it in an apartment, you can just do dumbbells pretty much because you want to hide it when you don't use it. But when you have a house, then you can actually have a real gym in the house. Yeah, let's just keep it like this for now, finally. And this is where we're gonna do this is where we're gonna move actually. We don't need is running anymore, do we? Or we do. I want it, but we're gonna do it like this. Oh. Do I want to split it up even more? Do I want to split it up even more? Actually. Fuck, how do I want to do this? Do I want this to be a sync as well? Not this one maybe, but... And then split these up. Yes. Or no. I'm moving a bit too quick now, I think, because we have this problem. This one. Update fluid mesh. We can't do this from a task. So we can't do this. But one sec. Yeah, the whole thing. What makes this so hard, or have made this so hard from the start, is that we have some parts that we can't thread. Oh, that sucks. But that's okay, I think. So what we're gonna do is so we can't do task run on this full method. Come on. But could we seriously do... We can basically do all of this, and for each of task run we send in cancellation token, and then we keep all of that within this one. The problem being we can't do this unless this one is a sync. So I wonder about this as well. Let's see here. Let's keep this one, because I think this is eventually what we want to do. But what bothers me a bit is this one. Not this one. We're actually very similar, but we can take this one. Because this call is not awaited, execution of the current method continues before the call is completed. Like this is what I want, but still getting this warning makes me wonder if we have a problem here. Because if we were to do it like this, we have add fluid async, and we just take like what I'm wondering if we could do this. He's running true stopwatch. We do if or try. I wonder if we could do it like this, and then of course, how weird would this be? And the only thing we do here is fluid solver token source. I guess we can do if is running fluid solver token source dot token, or just cancel. So this. If it's running cancel, which means that so these need to throw an exception, right? What's up, Didmogas? What is it? Unity? Yes. Yeah, so in the tasks we run, we need to do this check, right? I think I'm okay with that. It just needs to, that just means that we, or actually, yeah, we need to check for it. So it would pretty much look like this. Inside of this try, for each task we do, so this one, this one, this one, and this one, we send in token, I thought. So fluid solver token source, again. Right. Yeah, so this basically means, yeah, we can exit within here, 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 here. And this I never want to exit early from. Like this is making sure that that it's a stable state we have. But if we take, for instance, one of the easiest, so this one run here, move data, we just do this. This one I don't really. Yeah, this one we want to finish. So yeah, so when we get to, so things like move data, recalculate fluid mesh data. Yeah, this one and this one, I don't think we want to quit those. But we definitely want to be able to quit this one. I wonder is this a clean way to do it? I'm skeptical. I'm skeptical. And this also means that now I wonder, can we do it like this? Yeah, we can. We can. Okay, pull on this if you need to do other cleanup. Okay, so maybe we don't need that. So basically we could just do, we can run find reachable minima. For every while loop here, we check if it's cancelled. And if it is, we just cancel it. But we want to do this one as well. Okay, so here we want to pull it. Or actually, actually, what the fuck? I think we could, I think it would be way nicer if we add the try catch finally around this one only, because then we can custom this code. We can customize this in such a way that we do different things depending on where we exit. So for instance, if we exit during find reachable minima, the only thing we need to do is to move whatever we have in water to water previous, and whatever we have in water previous to water. We just switch those. But on the other hand, if we cancel during step 2, there's going to be but then again, if we just add it here, we're still going to continue with this one after. So yeah, that will not work. I have a lot of things to think about here, how I want to structure this. But then again, what we could do is, okay, this is pretty nice. So if we exit during okay. So it's up to these methods to properly clean up the data within the method, so that we can clearly work with it here. Okay, I think that's nice. So whenever we get to this point, we're gonna assume that water is the latest state we have, I think. So the only thing we want to do here basically is remove these and just keep these. Recalculate fluid mesh data, update fluid mesh data, and clear. And then this one, of course. And then it's up to whatever task that can be cancelled to figure out the rest. Yeah. Maybe. Yeah, I think so. So I don't care about token here. I don't care about token here, nor here. Step 2, so find overflow parameters, is also going to have a cancellation token, but none of the others. So for instance, if the cancellation happens within this one, yeah, if the cancellation happens within this one, we don't do this stuff. But okay, I think we're gonna clean this up a bit, make it more structured, but we're gonna have to do it tomorrow. But what I'm thinking is this one, it calculates affected points, and that's about it. And we're gonna wait with this one. Yeah, I'm gonna have to move real slow here. But it's basically, we can have it something similar to this, and on the crucial parts we add a cancellation token and we handle the cancellation, and move forward with the assumption that that's the only places, like all the places where cancellation can screw things up, that's when we have a cancellation token and handle it. I think this might eventually, this will be a good way to do it. But yeah, we're gonna have to find out tomorrow, because I gotta run. But as always, thank you so much for watching, everybody. Appreciate it, and have a great rest of the day. Peace.